Hey hackers, Blue Cosmo from CCS here, and welcome to Module 4, the last module for this course. So today we're going to cover some more ciphers and some other things you should basically kind of need to know if you want to enter the cryptography world. So I guess we just, dive in and get started. So the first thing we're going to cover is the Vigenere Cipher. Now the Vigenere Cipher, please be taking notes by the way. So the Vigenere Cipher was created by Giovanni Battista Balasso in 1553. You can see some of his information here. A more advanced version of this cipher was created by Blaise de Vigenere, which is who they named it after, right? It's also called the polyalphabetic cipher, but we don't really need to worry too much about that, right? So we have an indexing chart, and it's a little bit different from the Caesar cipher one, but not completely, right? So you can see that each letter has an index. So A is 0, B is 1, C is 2, D is 3, all the way to Z being 25, okay? Now, this chart will be very important throughout encrypting or decrypting with the Vigenere cipher, all right? Because this is what we're going to rely on to decrypt, all right? Now, for this example, we will be using, the key, the word key, K-E-Y, as our key, all right? Now, please note the indexes of our key. So our key is 10, 4, 24. Now, K10, because if we go to our K has the index of 10. Our E is 4, because our E has an index of 4, and Y is 24, because our Y has an index of 24, all right? So that's where we get these indexes from. This is basically how we're going to map out our ciphering process, all right? So now we can actually, encrypt our plain text. So the plain text we're going to encrypt is called encrypt, right? So we're encrypting this message, and the message is encrypt. So we can get the index of each character within this message, right? E is 4, N is 13, C is 2. You can see here, like, E is 4, N is 13, C is 2, and it just gets the indexes of each character from our message, right? So now, this is where the actual encryption process is. This table right here kind of represents how we can encrypt using the Vigenere cipher, right? So again, we have our plain text message, and then we get the indexes of our plain text message, all right? Now here is our key. Remember our 10, 4, 24? All we're doing is adding our values to the indexes. So we add our first key, or our first index of 10 to 4, and we get 14. Then we add our second key value, which is 4, and we add it to the next one, which is 13. Then we add our next key value to 2, and that gets 0, because we go to C, and if we go down 24 indexes, it will take us back to 0, because we have to loop over, right? And then if you add all those values and you get these new indexes, these are going to be the indexes for our ciphertext. So we'll go to index 14, and that's going to be O. So that's our new encrypted character for the letter E. And then we just do the same process for all the other letters, right? So N, our new index that we got is 17. So we can go to the 17th index right here, and that's R. So now that new character is R. Then it's A, B, C, and D. So now our new encrypted message is right there. Now, the decryption process is basically the same thing, but this time we're subtracting the values, right? So we take our ciphertext, which is this message right here. Then we get the indexes of our ciphertext, which is right here, and this is the same thing that you see right here. Now we're just subtracting the values so we can go backwards, right? So now 14 minus 10, that's 4, and then 17 minus 4, that's 13, and then we get these new indexes. Now these new indexes right here are going to be our plain text indexes for the plain text, right? And if we go to 4, we can see that 4 is the letter E. And okay, that's E, and then we just repeat this process until we get our plaintext message, which is encrypt, okay? It's very simple. Now, something cool that a lot of things, well, you can see how this can actually be a little bit more secure, right? Because we can make our key as long as we want. We can, make our key whatever we want, because it's going to be more secure that way. Another part about this as well is that it is we can change these indexes, right? So you can have a Vigenere cipher where these values don't even have to be in like a numeric order, I guess, right? You can have this be 2, this be 5, this can be 28. This can be like 17, or you can have just a shift of indexes, like the Caesar cipher, right? You can shift all these values by 5. So even if someone encrypts it with the default table, they still won't be able to actually decrypt it because they still need to shift all the characters by 5, but they don't know that, right? So you can make this a lot more secure. So this is a symmetric encryption process because it does use the same key to encrypt and decrypt, but you can see it's a lot more secure than the Caesar cipher, right? Cool. So now let's dive into Base64, all right? Now, Base64 is a encoding, right? It's not an encryption, it's an encoding because it doesn't use a key. We did cover Base64 a little bit earlier in the course when we were talking about password hashing, but now we're going to actually dive a little bit deeper on what Base64 is, right? So again, it's a ciphering process that uses binary data to encode text, right? Each digit is composed of 6 bits, rather than binary, which is composed of 8 bits, right? This means that 4 Base64 digits is equal to 3 binary numbers, right? Because 4 Base64 digits would be 24 bits. 3 binary numbers would also be 24 bits because it's composed of 8. 3 times 8 is 24, 4 times 6 is 24, right? So for every 4 Base64 digits, that is equal to 3 binary numbers. So, which means that's kind of like almost like a block cipher, but it's like a block encoding, right? Because of this, we may need to have a padding at the end, which is why we were able to tell that is a Base64 encoding in the beginning of our series, or we were covering password hashes, right? Now we have this table, and I have it open right here. And you can see we have a table of characters, right? Now, let me kind of clarify what's going on here. So we have a table similar to the table that we have for our Vigenere cipher, right? A has an index of 0, B has an index of 1, C has an index of 2, and etc., right? So in here, A has an index of 0, B has an index of 1, C has an index of 2, and so on. Now, these indexes can be represented by binary numbers. Now, the binary number for 0 is straight zeros. The binary number for 1 is 00001. Binary number for 2 is this. Binary number for 3 is this. Binary number for 4 is this, etc., etc., etc. All right? So with this table, you can see how each respective number, or binary or decimal, it doesn't matter, represents the index of an uppercase letter. Then it will represent the index of a lowercase letter. And then it represents the index of a numeric decimal, or a numeric number, right? And then finally it represents a symbol. This order of characters is part of ASCII, which stands for the American Standard Code for Information Interchange. And it's basically just the national standard that all encoding processes follow in America, all right? So what our Base64 process is doing is for every 6 binary bits, it's just applying it to this table. So when we're, I'll have my terminal open. If we go ahead and echo out subscribe, and then we echo this out to Base64, we get this Base64 string. So the first 3 binary characters are equal to basically these first 4, right? and it's basically kind of just cycling over through that table that we had described earlier in our web browser. It's really not that complicated. It seems more complicated than it is, but Base64 is just basically the exact same thing as AES or the some other block ciphers, but it's just relying on this table of these 64 characters, right? 0 to 63, which is 64 characters. And that's it. That's pretty much all we're going to cover in this introductory level course. This should give you enough information about what, you know, certain ciphers are, and how different ciphers work. We covered asymmetric encryption, symmetric encryption, Base64, encoding. Now that you know these fundamentals, when you learn about a different cipher, it will be a lot easier to understand, right? So I did cover all the main ciphers you'll typically come across, but there are a lot of encodings and a lot of different encryptions that you will see and you will learn about. But because you have this fundamental understanding, they won't be that complicated, right? You'll understand them very easily, and now you are basically set for most cryptological task at a beginner or intermediate level. Regardless, that's the end of this course. So if you guys did enroll or take this course on my website and enroll, you guys can get a certificate for this course. It's on the website. It's really cool. Actually, I'll show you guys that right now. So on the website, you can go here. The link is, of course, in the course overview. This is the Introduction to Cryptography course. So you can enroll. The course, you know, enrolling in the course is optional. You can just click on whatever module you want to take and then just take the course. The video, of course, would be right here. It tells you what level each one is. It says beginner or intermediate. So it kind of lets you know what level these modules are. But now if you did enroll, you can go to your surveying certificate and actually get your certificate. Enrolling is only $15. The course is free. The only thing you're paying for is the certificate. So if you just want to take the course, you can just go through here and take the course. But if you want to enroll and get a really cool certificate and show your family that you completed this course and stuff, you can go ahead and click that enroll button and get enrolled. Anyways, guys, that's going to be it for this video. So make sure to leave a like, subscribe, comment, etc. And I'll see you guys in the next video or in the next course. There's other courses on this website as well, so you can check them out for sure. But again, that's going to be it. So make sure to leave a like, subscribe, do the whole YouTube algorithm thing, and I'll see you guys in the next one. So stay happy, stay positive, and as always, happy hacking.